ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ ಚೆಕ್ ಮಾಡಿ ನೋಡಿ ಬರ್ತಾ ಇದೆ ಪಕ್ಕ ನೋಡಿ ಅಡ್ರೆಸ್ಸಲ್ಲ ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ Madam, good afternoon. Can you hear me? Richa, madam, can you hear me?
Yes, sir.
Shall we start? Shall we start?
Yeah, we can start.
Okay, fine. Good afternoon and most welcome to Dr. Richa, Varshney, madam, and all the participants to the program. So today's training session is actually the status of augmentative biological control in India, challenges and opportunities, which is going to be engaged by Dr. Richa Varshney, and she is currently working as Madam is currently working as the scientist at National Bureau of Agricultural Insect Resources, Bengaluru, which is an affiliate of Indian Council of Agriculture Research. And Madam is immensely talented, all by the way, like now, very evident in her CV itself, like now, from the childhood itself, like she was honored from the Akhila Bharatiya Vidya Parishad and Bharat Vikas Parishad for getting first position in the intermediate among the girls at the district level. So this shows from the childhood itself, she was immensely talented, and she finished her PhD program from GB Pant Agriculture University of Agriculture and Technology, Pantnagar, during the year 2007 and 2010. Apart from getting the PhD assistantship, and she is also the Madam is recipient of the Young Woman Scientist Award 2019 for significant contribution in the biological control by Dr. B. Vasantraj Foundation. And Richa Madam is also a recipient of Dr. B.S. Bomannavar Field Research Award for the Best Innovative Biocontrol Research for the year 2017 and 18 for the work on the management of major lepidopteran insect pests through timely supply and use of Trichogramma species. And she also has attended several conferences, among which 6 are they are the international category. And she has also several publications to her credit, and the best oral presentations. She got the prize as for the PI, and another tally is the best poster presentation 2 in number. And she has in fact accomplished 2 extremely funded research projects, and she also has worked as a co-PI for the 2 extremely funded programs, the research projects. And right now, as she is working in the National Bureau of Agricultural Insect Resources, Bengaluru, and apart from that, for her credit, the Madam has several publications, among which 23 are the peer-reviewed journals, they are 23 number, and the popular and extension folders, they are 10 in number. And Madam has also edited one book and 7 book chapters, and manual chapters are 22 in number. And she has also edited compiled 5 training manuals and edited AICRP biocontrol and reports 5 number, and the conference manual also the one. And she has also guided the 4 students interns for 6 months, and MSc and the PhD they are on roll. And now I would request Dr. Richa Varshney Madam to take the charge and commence the proceedings, please. Thank you very much, ma'am. Welcome to the program once again.
Thank you very much, Dr. Patil sir, for such an elaborate introduction. Though I don't need that much, and I may be very junior to all of you, but whatever I have done and whatever NBAIR has done in the field of biological control, that I would like to share with all of you through my presentation. Is it visible, sir?
You click on the present. Okay, now it is coming through.
Yeah.
Okay.
A very good afternoon to all the participants and all the faculty member. I would be presenting on status of augmentative biological control in India, challenges and opportunities. I would like to first tell the audience that that I'm working in NBAIR. Our bureau is recognized for the documentation, collection, and characterization of insect, whether it is insect pest or natural enemies. So we have a live insect repository where we are multiplying 130, more than 130 insects round the year, which includes host insects, predators and parasitoids. So on the basis of that, what request we are getting from all over India, whether it is farmers or students, academic institutions, private organization, government organization, and also we are also having AICRP biological control, in which we are taking large scale demonstration with well proven technology. So on the basis of these two things, I would be presenting my presentations. So here we all know what is a biocontrol. The first term was coined by H.S. Smith, though because all our faculty, they all know, but still I feel that students are there, so they can also know this thing. Then later, Paul D. Bake, in 1964, he refined this term and he distinguished the natural control from biological control. So in one way, the natural control is happening across the world in every ecosystem, and it has been occurring since the evolution of the first terrestrial ecosystem came into existence some 500 million years ago. It doesn't need any human interventions. The difference is that. On the other hand, biological control is the action of parasite, predators or pathogens in maintaining another organism populations much lower average than would occur in their absence. So this is a typical biological control definition. So if we go further, there are the three categories of biological control. Classical biological controls. Nowadays, some researchers, they are involving inoculative biological control into classical biological control, in which what we do, we collect the natural enemies from the exploration area, where this is the area which is having the origin of the pest, and then after collecting, it has been released to the area where the pest was accidentally introduced. So basically, it is applicable in case of invasive insect pest. So that is also happening recently. You all people know that the fall armyworm is an invasive pest, for which we are having natural parasitoids and predators and pathogens which are working well, that I will be taking in my presentation. And the conservation is nothing. It requires human interventions in terms of to protect and to stimulate the activity of the natural occurring natural enemies through habitat manipulation or by stopping some practices which is harmful for the natural enemies. And then comes augmentative biological control, in which what we do, we multiply the insects, the potential natural enemies, in a biofactory kind of things in a large scale, and then we are periodically releasing into the field to maintain or to reduce the pest population. So now, what are the key players in augmentative biocontrol? So if we talk about augmentative biocontrol, this is very old concept. If we go back way back to 17th century, in 1734, it was Reaumur who first advised the use of rhizopids for managing aphids problem in the polyhouses in European countries. Later, there was Erasmus Darwin who advised farmers to use the hoverfly or the sylphid fly for the management of the aphids, and later the subsequently other workers also came forward and then they suggested some things. And then there was a Metaphycus species which was produced in a large number and released. And then when the discovery of trichogramma happened, then the cottage industry, earlier it was a cottage industry where they have developed the mass rearing protocol of the trichogramma and other Epiphytes species, Potaceous species and all. And when they saw that it is actually the farmers are availing these things and the big industries are using these products, then suddenly this augmentative biological control has taken a big way. And now the market is very huge, which I'm covering in my next slides. So here I will be talking in terms of the insects, though pathogens also play a very important role in augmentative biological control, because I have expertise in insects, so I would be talking about insects only. There are the two categories: predators and parasitoids. Let's come to the predators. There are many predators and parasitoids that they have been documented against different insect pests in different ecosystem, and time by time there were some predators which were multiplied and they were released to manage insects. For example, coccinelids. Earlier, coccinelids were multiplying in the PDVC and they were using against the aphid, scale insects and other things. Here, I would be covering those predators and parasitoids which are currently being reared and which is having a demand by the farmers or by the consumers and other stakeholders. So here, worldwide, if we see, there are the two predators in terms of coccinelids and chrysopids, that is the Cryptolemus montrouseri and Chrysopelagus strobissalami, which has a huge market both in India as well as in abroad countries. And besides that, we also have the Blactocetus paliscens and other anthocorid, merid, and geocorid bugs, which is a new bugs, potential bugs. And if we see in abroad, they have been utilized by the greenhouse workers to manage sucking insect pests in polyhouses. So in our bureau, we have Blactocetus montandunella, they all are anthocorids bug. Cardiacetus exiguus, which is a very good predator of eggs and early instar of the black-headed caterpillar. Xylocoris flavius is a good predator of a stored grain pest. And Geocoris ocropterus, it is a general predator which feeds on whiteflies, thrips, spider mites, etc. Then if we talk about parasitoids, everybody knows that the trichogramma, it holds the first position because the coverage area is huge in terms of the trichogramma, whether it is Trichogramma chilonis or japonicum and any other species. Besides that, nowadays this Telenomus remus has got a significant position because of the invasion of fall armyworm, because it is an excellent parasitoid, egg parasitoid of Spodoptera, Frugiperda, Litura and many other insect pests, which I will be talking later. Then Gonuges nephantidis, we are also producing, and many horticulture biocontrol labs also, they are producing Gonuges nephantidis to tackle black-headed caterpillar. Chilonus blackburni, it is a egg larval parasitoid which is being used in potato ecosystem, and recently we have found that this species is also parasitizing for eggs in the laboratory. That also I will talk later. And then Potatia vestalis, it is an excellent larval parasitoid of Crutella, and Acidophagous papayi we all know. Besides that, there is a Bracon habiter and Bracon brevicornis, which are also being reared in many of the insectaries in India, which is funded by government. Now I will take one by one. Here I would be discussing major parasitoids and predators and how we can go for their mass production, just little bit information about it and how they are being used. So let's take an example of the Trichogramma. In India, we have the 25 species of the Trichogramma, in which 12 are indigenous and 14 are exotic species. And out of these 25 species, though we have collection of 25 species, but 10 to 12 species are only being utilized in different ecosystems to tackle different insect pests, and majority is Trichogramma chilonis, Japonicum, Aki, Trichogrammatoidea bacteria, Proteusum brasiliensis, Embryophagus, etc. Besides that, we also have Trichogrammatoidea species, 4 species. One, that Trichogrammatoidea bacteria is very good parasitoid of pink bollworm that has been tested in field as well. Besides Trichogramma normal species, the natural species, we have also developed some strain in which, though there are the 5 categories of the strain which has been developed for the Trichogramma chilonis, but this high temperature tolerant strain and multiple insecticide tolerant strains are in huge demand by Punjab workers. That Punjab is sugarcane, it is being used, we are using for multiplication of Trichogramma and other parasitoids and predators. So earlier I talked about the Trichogramma species which are being multiplied on Coursera. We have also developed one technology, that is the Erisilcom X. We are using to multiply Trichogramma chilonis and Ambrophagum. And the USP of this technology is that from one egg we are getting almost 15 to 20 adults of Trichogramma chilonis, which is sturdy and which is having a long life also. That has been evaluated in sugarcane ecosystem and it is working well. In Mandya, in some places, some farmers, they are utilizing, where they can avail the Erisilcom eggs, they are using these eggs for multiplication of Trichogramma chilonis. So these are the species of Trichogramma. For example, Trichogramma ambrophagum and cacosi. It is being used to manage Cydia, that is a moth, in apple, and chilonis in pomegranate berry. So many species of the Trichogramma are there. They are the working species which are currently being used for different insect pests. Recently, to tackle the fall armyworm, we have used Trichogramma chilonis, and we have also got natural parasitization of Trichogramma chilonis in the field. Then we all know how to release the trichogrammatids. There is a one card which has to be divided into the 16 pieces, and it has to be stapled on the lower surface of the leaf, and make sure it has to be released either in the morning hours or in the evening hours, and just avoid the spray of pesticide when we are going for release of trichogrammatids. So here, this table shows the doses of Trichogramma chilonis against different insect pests. For example, Trichogramma chilonis, these are the target pests like sugarcane borers, Helicoverpa in different crops, Chilopartylus in maize, Butella xylostella, 50,000 per hectare. Trichogramma japonicum also is being used in sugarcane and paddy to tackle top shoot borer and this paddy stem borer. Trichogramma achy is a very good parasitoid of Tuta absoluta, where the recommendation is 50,000 to 1 lakh per hectare depending on the infestation level, and 6 to 8 releases are recommended. However, the releases can be more releases can be done on the basis of the level of infestation and on the basis of whether you are going to use this Trichogramma alone, or you are using this along with some other interventions like some chemicals or some neem product or maybe some BT. As I mentioned that the fall armyworm has come, we have evaluated Trichogramma chilonis. So we have found that the 1 lakh per hectare dose is sufficient, and 3 to 4 releases in mazes have to be made for the control of fall armyworm. Similarly, there are Proteosum, Ambrophagum, Trichogrammatoidea bacteria. Also recently we have done large field scale demonstration with this parasitoid against pink bollworm in Jalna and in other area of Maharashtra. Then next parasitoid is Anastatus acheronchi and bengalurensis. It is a very good egg parasitoid of lychee sting bug, which is a major problem in Bihar. So we have developed production technology and we have evaluated this in Bihar region also. Right now, whenever there is a problem, they ask for us to supply this. However, we are trying to hand over this technology to those scientists so that they can work better. Then I said that the Telenomus ramus, it has got significant role now. So this species we are multiplying on the Spodoptera litura as well as Spodoptera frugiperda eggs. So there is a technology how to multiply the Spodoptera litura and frugiperda on diet, and the eggs which we are getting, we are exposing with the Telenomus ramus, and there is a recommendation of 20,000 to 25,000 per hectare to tackle fall armyworm. The next is the Chilonus blackbunny, which is a parthenogenetic egg larval parasitoid. This has been evaluated against potato tuber moth in Punjab area, and the recommendation is 2 releases at 50,000 adults per release. Recently, along with Trichogramma and Telenomus, we have also got species complex of Chilonus on the fall armyworm, in which one species has been identified as a Chilonus formosanus, and the rearing protocol has been developed in our bureau. And to our surprise, in northern India, the percent parasitization by this Chilonus complex is reaching 40% nowadays during Rabi Kharif season. So it is showing very good results, and now we are evaluating this species to tackle fall armyworm problems. So here is a rearing protocol. The rearing protocol is just same as a Chilonus black bunny. First, the egg card has to be exposed to this parasitoid for 24 hours. After exposing, it has to be taken out from the adult parasitoids, and then it has to be transferred once the larvae are hatched, because it is an egg larval parasitoid. So once the larvae of fall armyworm hatched, it has to be for some time it has to be reared on the castor leaf and then transferred into the diet. Here this is a diet, you can see this is a fall armyworm larvae on which Chilonus formosanus is developing. And then the total developmental period is 25 to 27 days. After once the cocoon is formed, it has to be collected, keep in the ventilated container. Once the adults are emerged, they can be released into the field. So right now we are working on the different doses of this parasitoid. So as of now, the 2000 to 3000 per acre, it has given us very good result, but still the experiment is in progress. The next is the Gonorrhea nephritis. As you are the horticulture, you are working in the horticulture stream, so you must be aware about the Gonorrhea nephritis. And I know that one of your unit is multiplying this Gonorrhea as well on the Corsera cephalonica larvae. So usually this parasitoid prefers third to fourth instar, and this is being multiplied on Corsera larvae. And how these are packed and shipped to the different stakeholders. Then again is Cotesia vestalis, which is a very good solitary larval parasitoid, endoparasitoid of Clutella xylostella, and it has got some resistance to some of the pesticides also. That work is going on that. Now recently, this is Bracon brevicornis, which is also being multiplied by some of the horticultures, and as well as TNAU, some insectaries, they are maintaining this Bracon brevicornis and habitat also. But recently we have evaluated this Bracon brevicornis against fall armyworm, and that we have submitted manuscript which is under review. So it works very good against fall armyworm, especially on the 4th, 5th and pre-pupal stage it is not accepting, but 4th, 5th it is accepting, multiplying and maintaining the generation. Then papaya mealybug parasitoid, you all know what was the papaya mealybug problem. Then we have imported, NBAIR imported these three parasitoids on which Acidophagous papaya worked best, and it was imported, then multiplied and then distributed among farmers across India wherever papaya is grown, and we have got very good results. This is an example of classical biological control, but still we are maintaining this species so that if further any infestation comes, we can tackle the problem. Now coming to the predators. So predators, we know that the Chrysoperla carnea or Jastrovi this is the predator of Chrysopidae family, which is being multiplied extensively and being used widely across the globe. So here there are the two family, Chrysopidae and Hemorrhoidae. So Chrysopidae, that Chrysoperla Jastrovi is working well. These are the 4 genera of Chrysopidae like Melada, Des, Jardinsi, which is working well for the whitefly also, and the Pseudomalada astur is another very good chrysopid which is recently working well against rugose spiraling whitefly. Then Chrysoperla we have the rearing protocol. Coming to the Hemorrhoidae family of subfamily of the this Neuroptera, this Micromus igorotus. It is earlier when the sugarcane woolly aphid problem was there, it was multiplied and then released against sugarcane woolly aphid, and it has provided substantial results. But nowadays that research have been done in the past, and they have provided, we have got very good examples also. But a huge demand is for the Chrysoperla and the Pseudomalada astur for tackling whitefly and other different sucking pests. So here we know that the Chrysoperla gestrovi salami can be reared on the UV treated eggs of the Coursera cephalonica, and it is being recorded. It is a predator which has been recorded on different ecosystem, on different insect pests, and it is also feeding on the eggs of the pentatomid bugs, green grams, sugar, sorghum aphids, etc. So this is a rearing protocol, how it is being reared. So I'm not going into detail in that. So this table shows how the Chrysoperla species being evaluated. Just a minute. Chrysoperla species are being evaluated against different aphid, whiteflies, thrips, and other problems. That this table shows the how many species of the chrysopits have been recorded on different ecosystem against different pests by different Indian workers. That means almost every ecosystem you will find one and another chrysopits. So that table is still going on, and we are compiling that also. Now coming to predatory coccinellids, we know that there are the different kinds of the coccinellid predators. Some are aphid feeders like Chilominus, Sex maculatus, Coccinella harmonia, Coccinella transversalis. Some are millibug feeders, some are scale feeders. So among out of coccinellid predators, rearing protocol has been developed, they have been evaluated also, but the rearing of these two predator is easy because we go for those predators and parasitoids which are amenable to rearing. So we cannot rear continuously these aphid feeders, because for that we have to maintain three systems like host plants, then aphids, then these predators, and we cannot produce in a huge number. But Cryptolemus montrouseri, Schimnus coxivora, that can be multiplied throughout the year on pink millibug on the pumpkin, which is very simple protocol, and I think most of the insectary they are following that also. So that Omkar and Parvez, they have compiled data, and what they have found is that the Cryptolemus montrouseri Indian work they have compiled, it was evaluated against the Planococcus citri and Macunelli coccus in India, in grapevine and camel, and then this Coccinella septempunctata has been evaluated against Lipophis on mustard, again by some workers, and again for the scale insect, this Chiloporus nigritus, it was found effective against different coccids for its scale insects. So if we talk about all the coccinellid species, as I have told you earlier, that recommendations is there, but if we talk about Cryptolemus and Schimnus, there are the doses for the grapes, approximately 1500 to 2000 beetles per vineyard has been recommended, and in case of the Schimnus, 2500 to 4000 beetles. Right now a lot of Fericia problem is there in guava and other sitafal and others. For that also we are recommending Cryptolemus montrouseri. Now that were the they were the classical examples of the predators and parasitoids. Recently some research has been done on the new potential predators. Among these potential predators, anthocorids are first. These are the bugs, hemipteran bugs, and they are the general predators of thrips, whiteflies, aphids, and mites. So these are the anthocorids which has been recorded in India, and they are being continuously multiplied. Among these anthocorids, some anthocorids they lay loose eggs on the basis of the rearing protocol I am telling, and some anthocorids they lay eggs on the beans, because in the laboratory condition we cannot use the natural plants, so we are using beans for the egg laying. And among them, this Bleptocystis paliscens and Aureus tantalus we have, that species are working well against broad mite. This Bleptocystis is very good predator of broad mite and red spider mites and thrips. Similarly, Aureus tantalus has been evaluated against thrips only, that I will be talking. So, in India, Blaptocythus palisans, it is an indigenous predators. It has been evaluated against Chilopartylus in maize, Tetranicus urticae, different mealybugs, Frankionella schulze in capsicum, and Tuta absoluta, and it is giving good results at the rate of 20 adults or nymphs in 1 meter square, and 3 to 4 releases are sufficient. But again, releases have to be increased or decreased on the basis of the level of infestation. Then this Cardiacithus exiguus, I also told earlier, and Aphanis both are very good predator of eggs and neonates of black-headed caterpillar, and they have been evaluated. Recently, this Aphanis has also been evaluated against Frankionella schulze. These that was anthocorids. Now coming to the merit bugs, there is a theory or there is a concept that merit bugs generally they are the phytophagous. It is not like that. Some merit bugs they are phytophagous. Some merit bugs they are the zoophytophagous like Nesidiocoris, which is found abundantly in tomato plants, and some merit bugs are exclusively predatory in nature. So recently, we have identified one Tortoise primarius. It is a merit bug and it is exclusively predatory in nature, and that has been evaluated against thrips. So recommendation is like 20 nymphs per plant provided substantial reduction in the thrips population. Similarly, this bug was also evaluated against Tuta absoluta in the cages, and now we are doing in the greenhouse study. So, just to find out whether this is exclusively predatory, what we have done, we have released this predator along with Tuta absoluta and without pest, just to see whether it can survive or not. So here you can see that when the Tuta absoluta pest population was there, it could survive. It reached to the peak up to the fifth week, and then it started declining because the tuta population also declined. But in the absence of the tuta, it could not survive beyond fifth week. Similarly, in the presence of Tortoise primarius, tuta population was very less, and it reached to the peak on third week and then started declining. So now the Geocoris ocropterus, this is geocorid bugs, and it is a common general predator. Dr. Ananta Krishnan, they have done a lot of work, but we have the rearing protocol in place where we can produce these bugs in a large number, and it was also evaluated against thrips. And this is the laboratory evaluation where it shows that the fifth instar and adult, they consume more number of the thrips when the density is 1:60, and third instar and fourth instar consume more number of the thrips when density is 1:30. It was again evaluated against the red spider mites, similarly the Tortoise primarius. Then this table shows the polyphagous predators. Most of them are being utilized in European countries in in greenhouses where the demand is more. But in India, the bugs or the name which you see in the purple, they are the bugs which are indigenous and they are being used in Indian conditions in greenhouses. This table shows the successful field releases of anthocorids in abroad as well as in Indian conditions. For example, Blaptocythus, it was that also I have earlier told you. And then it was also evaluated against Corsera cephalonica and Cytotroga cereella. Then Cardiacithus exiguus, it was evaluated against BHC in India. Then Xylocoris flavipus, it is also evaluated in Corsera and Cytotroga cereella. Then coming to the case studies, now we know that there are the trichogrammatid, they holds a first position when it comes to the augmentative biocontrol. So I would be presenting some case studies. First study is in coconut, there is a rugose spiraling whitefly problem. So it was invaded in 2016, and then we got the natural parasitization by Encarsia gudulopi and Encarsia dispersa. Now we have developed Dr. Selvaraj is there in our institute. He has developed the rearing protocol of this, and this Encarsia gudulopi, along with other interventions like Iseria formosinesa, that is another fungus, entomopathogenic fungus, and the Pseudomallada ester, they have provided a very good control of rugose whitefly in different area that I will show in AICRPBC. Then coming to the IPM in rice, there is a greater Mekong sub-region. They were the first who, in collaboration with IRI, with tiny biocontrol company China, Kabi, Switzerland, China, and Malaysia, and other institute of the China, they come forward, and then they came forward, and then they started producing trichogramma to manage stem borer problem in the rice. So that project could bring the 11 trichogramma rearing facilities during that project. Similar, on same track in Kerala, there is a success story. There was a networking of the stakeholders where there was a group of the farmers who were practicing VIPM practicing. Then, along with the our institute, along with the State Agriculture University, that is a Kerala Agriculture University, Thrissur, NGOs, and the State Department of Agriculture and Government Biocontrol Labs, they all joined hands together, and then they started producing not only trichogramma but pseudomonas and other things also. And then they created a success story. So, in Kerala, there are the 1,000 Krishi Bhavans in the state, and there are the 50,000 Pathashekarams. This is the group farming concept. And then under this BIPM, they have covered 75,000 hectare of area, and they got very good results. And besides Kerala, in Andhra Pradesh, Araku Valley, tribal farmers have also adopted biocontrol technology, and they have developed a small unit where they are producing trichogramma to cater the local needs that I will be discussing here. So VIPM in rice, after incorporating all these things, all the interventions, there was an increase in yield by 165 kg per hectare, and the net benefit was rupees 4,584 per hectare. Now the third case studies for the fall armyworm. We know that this is the recent invasives, and when that invasives came into India, immediately many IMR, NBAIR, and other state agriculture university, they started searching natural enemies. So we have got many natural enemies, almost more than 15 natural enemies, in which we have got very good parasitization by Telenomus species, Trichogramma species, and Chilonas species. So to our surprise, the Telenomus species which we have got, which is naturally parasitizing fall armyworm, turned out to be Telenomus remus, which is already we are producing in our bureau. Similarly, the Trichogramma species turned out to be the Trichogramma chilonis. However, in Latin America and in Africa, they are using Trichogramma pretiosum. To us, that is an exotic parasitoid. But here we are getting our indigenous parasitoids, and it is working well, and it is showing the natural parasitization also. Here I would like to emphasize that Telenomus remus is also exotic parasitoid. In 1980s or 70s, it was imported from the France, and that time it was released to tackle Spodoptera litula in tobacco. But it has adopted in Indian condition in such a way that now it is parasitizing fall armyworm, and we are noticing almost 8 to 12% natural parasitization by this parasitoid in different states. And Chilonas, already I have told, there are 3 and 4 species of the Chilonas, in which one has been identified as Chilonas formosanus. That is also, and these are other parasitoids. So this is the XC2 conservation. All the natural enemies, egg or egg larval, which we have got naturally, that we are that we are multiplying and we are using also. So when we collected all this information and we are having the multiplication system in place, so we have devised IPM, biocontrol based IPM module, in which we have taken these parasitoid as one of the component, and we incorporated other components also, like pheromone traps, Bacillus thuringiensis, and Metarhizium, and then we have started pilot trial. Here we have got very good success, and that paper also we have published. So now that because now we got enough information, and we know what is the IPM module, and when we are supposed to release, and when we are supposed to spray the EPF. Now we have done we have conducted this trial in 75-acre area in Kadalaveni village in Chikballapur, Karnataka. So that trial is going on. Yield has to be done. So that was case study. Then, as I said, trichogrammatids. So this is the data. This is the data which is based on our information, means how much trichocards we have supplied to the farmers and to the government organization. On the basis of that, we have computed this data. So between 2003 to 2008, the area coverage under trichogramma was 4,000, which has increased in 2013 to 2018 up to 48,000 to 45 hectare area under trichogramma, different species of the trichogramma, covering different crops like cabbage and this cabbage, maize, paddy, and cotton. Then this was about trichogramma. Recently, we have developed this Neosulus indicus. In India, two predatory mites are being produced in large number. One is Neosulus indicus, which we have developed. Another is Neosulus longispinosus, which are being reared by many universities. Like in Himachal Pradesh, they are rearing is longispinosus, and in GKBK they are rearing longispinosus. So they both are working well against different pest sucking pests especially. So that technology has been developed for the mass multiplication, which is very easy technology, and it has been commercialized also. And bleptostasis was also evaluated against thrips. This is the technology which I was talking about. So these two predators we have evaluated against red spider mite on roses. So we have taken these two predators along with Hirsutella thompsoni, which is the EPF, and then miticide, and one miticide. And what we have found, that Neosulus indicus could reduce the red spider mite population by 87.21%, which was on par to the miticides. So when in terms of the eggs, when we consider the eggs of spider mites, it has provided this result. On the other hand, it could reduce 82.17% of the motile stage of the red spider mite, which was on par with fungus and miticides. Similarly, it was on rose. Similarly, we have also got broad mite problem in Karnataka region on mulberry. And the mulberry, we cannot use any other insecticide or miticides because this is the problem. So we have used this predatory mite as well as Hirsutella thompsoni to tackle this problem, and that has got very good results. Now coming to AICRP BC, you know that as such in India we don't have any program which is utilizing only biological control agents, but this is the All India Coordinated Research Project which includes only biological control. So here this is the table which shows what is the production of the predators and parasitoids. This is a one part. They are also producing microbials, which I am not taking here. So during 2009-14, the production of Trichogramma chelonis was 105 million. And 14 to 19 it was 172, and I said Neosulus longispinosus also is being multiplied, so it was the number was 1.14 million and 1.21 during 2014 and 19, and their coverage area is very high. This slide shows the area covered. During 2012 to 20, it was 34,397.32 hectare. But since AICRP is operating, I think 35 years by now, so 1990 to 2016, the area coverage was more than 5 lakh hectare under different crops and weeds. That time weeds were also included in that. And so many classical biological control happened during that time, which really. So here the major area was sugarcane. What the reason is that in sugarcane, especially in Punjab, they have collaboration with the sugar factories, and they are using temperature tolerant strain of Trichogramma chelonis, and then they have passed on this technology to the sugar factories. Then they are multiplying, and in the collaboration with the sugar factories, they are covering huge area. And this area is also for Andhra Pradesh. Means sugarcane is majorly we are doing in Andhra Pradesh as well as in Punjab. Then it is this area was 1823 was for paddy, then followed by coconut, and this area, little bit this area is having like vegetables, fruits and oil seeds. There are some success stories under AICRP biological control here. So as I said earlier, that Encarse guadeloupe along with Iceria fumiceraceae and Pseudomalada aster, it provided a net saving of 9,500 rupees per hectare, and there was a reduction in uses of the insecticide. So that is also very good, and this was conducted in Kerala, Tamil Nadu, Andhra Pradesh and Karnataka. Similarly, in rice, again I told in this was that BIPM module having Trichogramma japonicum, Vesiana, Pseudomonas is a directing and other things to tackle stem borer and leaf folder in Kerala, Orissa and Assam and Punjab. So the area covered was 7,800 hectare. Increase in yield was reported 165 kg per hectare, and there was a net saving of 4,000 per hectare in case of rice. In case of maize, the Trichogramma kilonis has provided saving of 10,360 per hectare. Similarly, the sugar cane, as I said, sugar cane woolly aphid, this Micromus ignoramus ritus that was used, and it has completely eliminated the use of chemical pesticides. And this Trichogramma technology also, it was for the sugarcane borers, covering area of 11,730 in Punjab, Assam, Odisha, and it has provided a net return of rupees 1,72,987 per hectare. Now coming to the protected cultivation. So as I said that the Bleptocethus, it works well for the thrips and red spider mites, and so they have done this. I'm taking just one example just to show how we can go ahead with these predators. So by using Bleptocethus pallescens under polyhouse condition, they could reduce mite population from 3.89 to 0.08 per centimeter. It was on par with the acricide. Similarly, Chrysoperla gestrovisalemi was also able to reduce aphid population on capsicum, and it was on par with imidacloprid and Licanicilium. And Neosulus longispinosus also, it could reduce 71% population of Tetranicus urticae on carnation, and it was on par with Neemban in Himachal Pradesh. So there are the few examples where we can say that these biocontrol agents are working and they are covering huge area. Now coming to the commercial production. If I talk about India, as such, there is no commercial insectary. One commercial insectary was opened in BCRL under PCI, that was in 1980s. That time they were producing Trichogramma, Potatia and other species. But now that BCRL is more into pheromone and the biopesticides, now they are not producing Trichogramma. So as such, we don't have commercial insectary in India, but we have government funded biocontrol, state biocontrol units, and some units which has developed at the village level by some of the universities. So as I told that Anakapalli, Anghu, they have developed one unit especially in the tribal area where they are producing Trichogramma and they are catering their local needs. Similarly, Raichur, they have also developed some units in Kalburgi and at Gangavati where they are producing trichocards. In Chhattisgarh area, again in the tribal area, they have developed Krishak Biocontrol Lab in the collaboration with 300 farmers where they are producing trichocards to cater the needs for paddy as well as maize. So these are few examples. Maybe there are many more examples, but later we see. So now coming to NBAIR, we are non-commercial unit. So we are like a bureau. We are maintaining the culture, we are supplying the nucleus culture to the different government organizations, and if the farmers request, we supply whatever maximum possible, we are supplying to them. So almost all across the India we are supplying. As I said, there are government funded biocontrol labs also. They are producing like one Ara Sikari Chori area. They are producing Brecon and Trichogramma and Gonuges. Again, there are some labs in the Kerala. They are producing Trichogramma. Okay, there are some labs in Northeast where the majority of them they are producing biopesticide, but few of them they are producing Trichogramma. But again, we don't know the status, how much area they are covering. So the linkage is missing. The linkage from the National Institute to the government, state government biocontrol labs, that linkage should be there. So we could come to know how much area we are covering under augmentative biological control with respect to the predators and parasitoids. So again, if we talk about NBAIR, so during from 10 to 18, we have almost supplied 5,300 shipments. Then more than 2,000 shipments have been supplied to the government organizations. Then 1,500 to the academic institutes, and then 500 to the private farmers. So this is our strength. As I told, that our repository is having 132 live insect culture right now, and during that period we have supplied almost 708.94 million insects, on which 518 were host insects, million were host insect, and 252.40 million were beneficial insects. So this is like and under MGMG, because 2017 onwards MGMG has started, so that are the insects which have been supplied to the farmers where we have adopted the village. So majority are the Chrysoperla, Cryptolemus and Trichocards only. The one problem with tricho, with the use of the maximum number of the predator and parasitoid, is how we can go for maximum production of the trichogramma. So recently we have developed one cage type of a structure. This is a 3-tier cage in which more than 200 cards we can produce at a time. Excuse me. So here, if suppose the demand comes, for example, there is a paddy season or maize season, so here we can produce more than 200 cards at a time. Now coming for the world scenario, that Von Lantern recently in one of the paper, he has mentioned that there are the 350 species of the biocontrol agents which are being produced round the year against 100 pest species, and these whole the 350 species, they make the world market of 600 million US dollar, which is a huge market of biocontrol agents. So out of the 350 species, 50%, more than 50% are occupied by Hymenoptera, 13% by Acari, 18% by Acari, then 17% by Coleoptera, and 8% by Heteroptera, where all the polyphagous bugs comes. So this is the list which he has given. This is a huge list of the 350 biocontrol agents, and out of the 350 biocontrol agents, 75% they are produced in medium and small numbers. The reason for that is that either they are required in less number. For example, if somebody wants to release, because in Europe and Latin America there is a culture of greenhouses or like kitchen gardens or something, so either they required in very less number, or they are occasionally required to tackle minor pests. So out of 350, 75% they are produced in medium and small number, maximum 100 or 1,000 in a week, and remaining 25% they are produced in large number, particularly trichogrammatids and acarids like mites. Maybe you can say 1 lakh in a week. So again, there are the two categories. Either they are produced in large number and to provide the control of in a very small area where they are supposed to be released in large number in case of predatory mites, say for example in greenhouse, because mites are very tiny and they need to be supplied in a large number. So in that one way, and in another way they have to be released in larger area but in small density. For example, trichogramma, for example, coccinellids. So this list shows these things. Then this is the worldwide use of the major augmentative biological control program, which is right now running in different countries, maybe South America, Mexico, USSR, China and other countries. So maximum you will see here, the maximum things are occupied by trichogramma species, though there are some examples of the Potatia and other natural enemies, but majority of trichogramma programs are going on in different countries in different crops, whether it is cereals, tobacco, or polyhouses. So these are the 25 species, these are the 25 species which is having mites or trichogramma and other things. And these 25 species, they are constituting 90% of the 300 million euro of the world market of biological control. So though there are the 350 species, but these 25 species are taking a major role in the biocontrol market. Again, NAP 2018, he further told that earlier what happened, that the trichogramma were in great demand. But right now, after 2006, since the discovery of amblyopsis swissky, which is being used widely in greenhouses in European countries, so after the discovery of this predatory mites, that market has been taken over by this mite. So these are the major, holders, major key players in the augmentative biological control. These are the some of the species of the commercially available mite species which are being used. As I said, that NAP 2018, he reported that before 2006, he works basically on the greenhouse biological control. So earlier greenhouse biological control, the major market was captured by Encarsia formosa for the whitefly. But now that these are the species of the mites which are taking over. This is the clippings of one the newspaper which mentioned that the market can be reached up to 75,091 million US dollar by 2026. It is a prediction. Now coming to the commercial insectaries. Actually, the commercial first insectary was there are the records. First insectary was started by Dietrich in 1950 in his garage, where he was producing aphids against the California scale. So from there that concept has come. So worldwide there are 530 commercial insectaries. Out of 530, 30 are large, in which 20 are in Europe, and major chunk is for the greenhouse or the glass houses. So 30 large means they are employing more than 10 employees, and 500 are the small commercial producer where they are having employees less than 10 people. So this is the scenario in the world, especially they are the Europe and the Latin America. Again, in the Latin America and Caribbean regions, there are the different countries which are having different commercial insectaries. For example, Colombia, it is having 30, but it reduced to 9 during 2010, it is by mistake it is there. Mexico, it is having 30. Peru, it is having 82. Cuba, it is having 284 macrobials as well as microbials. So here, since in India we don't have any commercial unit right now, but whatever, I just want to give you a glimpse of NBAIR. We are per year we are producing almost 43 million live insects. We are supplying in 1500 shipments. So this is like very small chunk we are contributing, but we could collate some information. These are the some companies who are producing natural enemies, and where we have provided the support in terms of technical support, or we have guided them how to go ahead. So these are these companies which are producing some of the natural enemies. Majority of them, they are producing either Trichogramma chelonis, Chrysoperla japonicum, Trichogramma japonicum, Chrysopids, and Cryptolemus. If we talk about world scenario, they are the major players in the biocontrol market. They are the 5 major companies. They are the NBAIR, Syngenta, Copart. So now, what are the challenges we have? So though people are aware in India about the biocontrol, but the availability is a big problem. Where they will get the biocontrol agents? They know that trichogramma is working. They know that this bug is working, but from where they are going to get it? So for that, we need to set up different units. We know that the biocontrol units are there, but again, I said that the linkage is missing. We don't know which insect, which predators and parasitoid they are producing. So we need to set up more units so that we can produce in large number. and we can cater the needs of the farmers, at least in our area, then more research should be done on the shelf life, because shelf life is a constraint for which the many of the pesticides company, they don't want to produce macrobials because of their shelf life problems. So however, some research we need to do in that. So recently we have developed this long term storage of the Trichogramma calenus, where we can induce the diapause when it is in embryo stage or pupal stage, and then we can store these trichocards for 95 days with maximum 65% of adult emergence. So like that, we need to do different researches to tackle this problem. Now, next is the attitude of pesticide industries. We know that the pesticide industry, they don't go for the substantial control. And as I said, shelf life is a big constraint for which that pesticide industries are not going. And the farmer's attitude also matters. The moment they see the insects, they immediately spray, and they know only by spraying only insects can go. Okay, they don't think that they are the predators and they are the parasitoid kind of things. Though slowly awareness are being created, but still we have to do a lot of work, and the government policies also. Hardly any government across the world, they have the policy where they can push the this type of IPM kind of things as a policy they can push. So that has to be taken care of that. Recently, one example is UPL. So UPL, this is the big company, as all of you know. Recently, they have started producing Trichogramma, at least for the pink bollworm in one of the area in Gujarat. So they are producing Trichogramma right now. The next is the strict guidelines and regulations of access and benefit sharing. There are the lot of regulations, rules, regulations and guidelines. If we want to export the natural enemy, if we want to import the natural enemy, how to ship them. So a lot of guidelines are there. And under the CBD law also, because now the biodiversity is a sovereign right. So every country has right over their biodiversity. But these rules somehow has to be, it should be little simpler, so that we can collaborate. For example, recent example, we know that cassava mealybug has come. So we are trying to import the Anagyrus lopezi, but still some problem happened because they were looking for the exchange earlier from the Thailand, but we could not provide because of some flaws in our rules. Either we don't understand, or either that rules have to be somehow simpler, so that research can be done in that aspect. So with that, I would like to thanks organizers UHS Bagalkot for giving me this opportunity where I can present our work. To my director ICR NBAIR for allowing me to present here, Dr. Satyanarayan, who was continuously in touch with me, and Dr. Vailalita, she is the Chief Technical Officer, who is helping me in maintaining insects. Because of her help only, we could be able to maintain 132 live insects. So thank you one and all, and I am happy to take your questions.
Okay. Now the topic is. Richa madam, can you hear me?
Yeah, I can hear you.
Now the topic is open for discussion, and if you get any specific queries over this particular topic, you can just ask Richa madam. She will try clarifying all those things. Are there any specific questions?
Hello, madam.
Yeah, tell me.
Madam, regarding the Tuta absoluta,
Kalmat is speaking from the US, right?
Yes.
Madam, among the different Trichogramma species for Tuta absoluta, so you told Trichogramma acai is better.
Yes.
So what is the percent parasitism it causes?
Percent parasitism. In laboratory, it is causing almost more than 60% parasitism. We have evaluated many species like Trichogramma, Pretiosum also we have evaluated, and other species, because the egg size is very tiny. So we have found acai is working well. So any species which is giving more than 50 or 60% parasitization in the laboratory, that only we are using in the field. So recently the Dr. Om Prakash is there. He is evaluating this particular species at different doses in the field condition.
Okay.
Along with other interventions.
Okay. I have also read Tuta absoluta, and I have also evaluated all Trichogramma species. So maximum of 30 to 40% parasitism is caused by proteusum, not
Okay.
a not bacteria, not the chilonis.
Okay.
Chilonis is almost on par, but
Yeah.
I could not able to get more than 40% with Achaea or proteusum. Proteusum and chilonis are little bit better, but
Yeah.
Achaea is not up to that mark actually.
Yeah.
That I have.
Are you sure that you whatever the species you are mentioning it is that species, because taxonomic identification is also important.
Madam, I have taken all the trichogramma from your lab only.
Okay, okay, okay. And let me
Okay.
tell you one thing. That Chilonis size is little bigger compared to the Eki, and Tuta absoluta size is also very small. So we
Yeah.
have found that in our condition, Eki is working well, and compared to the
Also,
Chilonis, because after one generation we cannot
yeah.
multiply it. Something is happening like this.
But I several times I did it. Okay.
Okay, okay,
Ake and Chilonis and Proteusum. Among that,
okay.
Proteusum was found a little better. That too up to 40 to 40%, I think. 30 to
Okay, okay.
40%.
And it depends on sex
So,
ratio also, whether are you providing 1:1 or like some 0.5:1. That sex ratio also matters in that condition.
okay. Okay.
Yeah.
So regarding one more questions actually.
Yes, yes.
For the parasitism, okay, to increase the parasitism of any parasitoids, is there any other ways to improve the parasitism?
Yeah, conditioning is very, very important, you know. For example, I tell you different examples. We are rearing trichogrammatids on Coursera. Okay. Sometimes conditioning is very important. For example, I give you example of Goniujas. Goniujas is a larval parasitoid. So we are rearing here on Coursera. It may not, we have done, like my seniors, they have done some experiment, and what they have found is that if they are exposing these Goniujas with the fecal matter of the this black-headed caterpillar during transition, when suppose they are shipping to other places, during that time if they will keep these Goniujas adults along with the fecal matter of BSC, so it will take some volatiles from that, and then it will show the high searching efficiency, and parasitism is more compared to the previous one. So conditioning is very, very important, whether it is a bracon or the Goniujas, especially in case of larval parasitoid compared to the egg parasitoid, because egg parasitoid they are having the innate behavior. So the programming is there, then they have to come out, they have to search, and they have to finish their life cycle within a short span. So like that we
But,
can enhance.
okay, can we improve the performance of the parasitoids with some radiations?
Radiations, actually I haven't worked on radiations, so I don't have the idea about it. Maybe if there are some reports, maybe you can try, but I haven't worked on that.
Okay, thank you. Thank you.
Thank
Hello.
you. Yes.
Yeah, this is Mr. Girish from Directorate of Floriculture Research, Pune.
Yes, sir.
Yeah, there are quite good natural enemies, especially this predatory mites. They
Yes,
are very
sir.
effective against this red spider mite.
Yes,
There's
yes,
a
yes, sir.
huge potential is there in India where a lot of polyhouses are being closed because of the mite infestation and thrips infestation and all.
True.
Even though your technology is that much superior in counteracting these red spider mites, why it is not coming into field condition? What
Yeah,
are the
yeah, sir.
problems?
Actually, yes, sir. One thing I tell you, recently only we have developed and we have commercialized this technology to one of the farmer in Maharashtra, who is a rose grower. So I am ready to happy to, because one technology may work at some places, one technology, that same technology may not work to other places. So I'm ready to share. If you want to try this mite, I'm ready to supply to you. First, you have a trial. If you feel that it is working well, then definitely you can go ahead for the commercialization or to take up this technology.
Yes, what is
Okay, we'll
exactly
think of
right.
that.
Yes, I'm ready to collaborate with that, because I also want to promote this product. So that,
With
because
this
mass
product-
ready protocol is very easy, sir.
Okay.
Anybody can produce in huge number. The thing is that we are looking for the polyhouses, like slowly we have done in roses, in mulberry, so where we have got very good results. So we are little bit encouraged out of these results, and yes, sir.
will this technology has been tested under ACRP biological control, madam?
Yes, 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 sir. It is being tested. It is tested, and now also it is being tested on other crops like carnation and other things. Yeah, it is being tested. Yes, sir.
Right. Hope so. We will have some collaboration.
Yes, sir. Yes, sir. Actually, Firake sir is there, right? Recently,
Yeah,
he
Firake is there, yeah.
So I already spoke to him because he was my senior. So if
Okay,
you
right.
need any collaboration, we are ready to do that.
Yeah, definitely, madam. Thank you.
Yes. Thank you, sir.
Are there any questions specifically from the audience side? Dr. Venkatesh is Professor and head here. This whiteboard seems to be asking, seems to be waiting for asking a few questions, ma'am. Can you take it?
Yes.
Madam, thank you for your nice presentation.
Thank you, sir.
Madam, usually with respect to Chrysoperla,
Yes.
we used to teach it like we used to refer this name as Chrysoperla carnea.
Yes, sir.
But now we say it is Chrysoperla gestrovis silemi.
Yes, sir.
So why this change has occurred?
Sir, actually, chrysopid is a very complex group. So, on the basis of the sound, courtship sound behavior, they are identifying that this is this species, that is this species. So, there is a specific behavior, sound system is there, sir, during courtship period. When they identified that particular sound is there and it is matching with this species, on the basis of that, we have identified this is Chrysoperla gestrovis silemi.
So that means earlier what we have identified carnea is a wrong identification.
Yes, sir. Carnea doesn't exist in India, sir.
Okay.
So it is like we can write sensolato because previous things also we are taking from that. Though I am not a taxonomic expert, but I know that carnea doesn't exist. Whatever the species we have right now, it is Chrysoperla gestrovis silemi.
So we thought it is actually synonym. So it has been synonymized.
No, sir. It is a very complex. The taxonomy of chrysopid is very difficult, sir. Very difficult. So there may be some groups, sir. I mean, I'm not denying there may be some species, but that somebody has to take up these things. Somebody has to collect those species and see their sound system, whether still it is gestrovis silemi or it is matching to something else.
Madam, one more question. So in pomegranate fruit borer, so in your trichogramma clone is the worst listed.
Yes, sir.
Yeah, so probably this is the only butterfly, the worst, what I observed.
Yes.
So this because this is a fruit borer, pomegranate fruit borer is a butterfly. That is
Yes, sir. Yes, sir.
Yeah, so it is a butterfly. So where the egg, the shell is very, very hard.
Yes, sir.
So when we given it to one of our students to study, we could not get any parasitides.
Parasitized eggs.
Yeah,
Yes.
so especially pomegranate fruit borer, but we could not get. So we could get from the carcera, but not from pomegranate fruit borer. Whether have you collected any parasitides from the pomegranate eggs, fruit borer eggs?
Sir, long back, Dr. Lalita only collected this parasitoid from this fruit borer eggs from the pomegranate. But as you said, that parasitization is very, very less. So maybe, yes, sir, maybe we need to increase the dose, or because earlier it was long back, it was evaluated under AICRP only in the laboratory as well as in field. So she collected this one.
Actually, that is a butterfly, no, madam. Eggshell is very, very hard.
Very, very hard, yes, sir.
Yeah, so we thought probably it may not parasitize. So something
Sir,
like
no,
that.
it is parasitizing. Parasitization is there. Parasitization is there. But recovery, I am talking about the recovery. Recovery is how much, that is a question. Parasitization is there.
So another, madam, preconditioning, where who has to do, whether the supplier has to do or at the release level we have to do. That's
So preconditioning, better to supplier should do that, sir.
So
When you are going for the shipping, like suppose you have collected some adults and you are shipping it to the different places. During transit also, if you keep something, I have given the example of gonuges. You just keep the little excreta. Do not keep more excreta, otherwise fungus will come, because this is water content is high. So either you can expose it first and then ship, or during shipping also you can do.
Thank you, madam. Thank you.
Madam, okay.
Yes, sir.
Somebody is asking.
I have one clarification. The predator of Augusperlin fly
Yes, sir.
Pseudomonada aster and the Dicotyledonous aster. Whether it is same or different?
Sir, it is identified as a Pseudomallada aster. Some chrysopid experts told. Earlier also we thought it is a Dicotyledonous aster only, but the name is now Pseudomallada aster. Yes.
Whether species is same, na madam?
Yeah, species is same. Species is same. Only the synonymy is there.
Synonym. Okay.
Yes.
Thank you.
Yes.
Any more questions from the audience side?
Any more questions from the audience side, please?
Madam, if
If you don't mind, like, there are a few questions which have been posted in the chat box. People probably relate, they have problem. If you can look, trace them out, that is fine. Otherwise, I'll read out for you.
Yes, sir. I just shall I this one?
Please.
Okay, 1 minute. Is Skimnus, are you supplying Bracon species? No, I am not supplying Bracon species from NBAIR because we have the Coursera production and Bracon is a threat. So there are the TNAU and I think one of your unit also multiplying this Bracon brapiconis, that is Arasikeri unit, I think, Bagalpur. They are producing, and TNAU also producing Bracon brapiconis, because whenever we need for the release into the field, we are taking from them only. I can share the address of where we are getting this Bracon. So otherwise, NIPHM is also multiplying Bracon habitat. You can also request, they can give you nucleus culture, but we are not producing Bracon species. Now second question is Skimnus coxivora commercially available? Yeah, we are producing Skimnus coxivora. You can write to me. Please write to me on NBAIR Live Culture, or I have shared my email in my presentation. So we are producing Skimnus. We can give you nucleus culture. We are not producing commercially, like we are the research unit, but I can give you, we can share, we can give you nucleus culture.
Any more
questions from the audience side?
Okay.
Okay, if there are no questions from the audience, Madam, actually, I have one question. If there are no
Yes,
more questions from the audience side, I will be
Yes, sir.
format of like chat box. You in one of the segments you said, like, the trichogramma kilonis and the trichogramma embryofagum.
So
you have used the very silkworm egg. What's your rationale or what's your logic behind using the egg? Because the process of is very
So rationale is that it is very because we went to some places where they are producing erisilform eggs and they are throwing that eggs, like some damaged eggs and something which are not hatching out. So we thought, why don't we use this eggs for the trichogramma production? So we have taken the eggs which is not of the very good quality for the hatching purpose. Okay, so we are taking, and some of the area where they are producing in large quantity, and besides that, especially in Mandya district, they are having the paddy cultivation also. So we thought, why don't you use these erisilform eggs for the multiplication of trichogramma, because Coursera they cannot multiply in a huge quantity. So where they are producing this erisilform, they can go ahead for this thing. And one more thing, that cost of setup is very less in case of erisilform compared to the Coursera. The setup is one-time investment in Coursera also, which is huge, which can come for the decades. But in here, the setup is also very less. Especially it is recommended where they are producing erisilform.
Okay.
So is there any the appreciable size variation in the trichogramma that comes out from the erisilform egg?
Yes. Size is little bigger.
case of
Exact what is the, and sturdy. It is having, suppose a trichogramma kilonis, it is surviving for 3 to 5 days normally, but it is surviving 7 to 8 days, and it is little bigger in sizes, and the parasitism ability is also on par with the Coursera, like more than 90% parasitism we got with that.
And
is there any significant variation or significant impact on the flight, the range of the? So because the trichogramma which is reared on the
Searching efficiency is more. Searching efficiency is more in case of erisilform strain compared to the Coursera strain. But we don't know what is the reason. We could multiply only these two species, Embryophagus and Chilonis. Though we have exposed to many species, but we have only got these two species. The reason we don't know. We are working on that. What could be the reason why it is not accepted by the other species?
So you in fact, like, elaborated in several aspects. So one is the fall armyworm.
Yes, sir.
and the parasitoid against that one, and the second one is Tuta absoluta,
Yes, sir.
and one more thing is okay. So papaya mealybug. Okay, papaya mealybug. Parasitoid. The natural one is this one. So you have the decades of experience. I mean, like, you probably have the several years of experience working on these parasitoid data. So what is, like, not the experimental that I'm talking about. In fact, what is your gut feeling? So which is the best against the fall armyworm?
So best against the fall armyworm is Trichogramma chilonis. Though Telenomus remus, I tell you why, sir. Though Telenomus remus is excellent parasitoid, it can parasitize the deepest layer because it lay eggs in the layers. But the production is the question mark, sir. For the production of Telenomus remus, we have to produce either Spodoptera luteura and or the Frugiperda, which we cannot produce in bulk. But Trichogramma chilonis, though it cannot parasitize the deepest layer, but it can be produced in the large number on the Coursera eggs, and huge area we can cover, which we cannot cover with Telenomus remus. However, what we can do, we have also found that both the parasitoids are complementary in nature. Okay, so if suppose one has parasitized the eggs, other would not go to that same eggs. So what we can do now, we are working on the ratio. Suppose we take some ratio of Telenomus remus and more number of the Trichogramma chilonis depending on the production, and in what ratio we should release to get maximum parasitization. Telenomus remus can target deepest layer and Trichogramma chilonis can target superficial layer. So that work we are doing, and yes.
So which say Tuta absoluta against that one? If you have a single line of recommendation, which would you recommend against Tuta absoluta?
Sir, Trichogramma ecki, though I have not done work on that, but my colleague, he is working on Trichogramma ecki parasitization on Tuta absoluta, and he is doing field trial also. So he only told me that Trichogramma ecki is working well compared to the Pretiosum. Pretiosum is on par, but ecki is working well compared to the other species.
But madam, do you have any publications regarding that?
Yeah, publication very soon it will come, but we have foreign countries publications where they have mentioned that ecki is working well and Pretiosum is working well.
Yeah, I think
We have. I can
think
share with you that publications.
I think you need to recheck it because the personal parasitism of
I will find out with my colleague because I'm not working on that.
that's
But
very
I will
important
definitely
because
find out with him, as you have one doubt on that. So
We
definitely
have-
I will reconfirm with him.
we have
What is his?
collaboration bark and we have done there also, here also.
Okay.
We could not able to get more than 50% actually.
Okay. I will recheck with him once again and get back to you.
Okay. So finally, what I would say is, like, the Vasparaj Kalmat probably was little skeptical. He was little skeptic about the.
Yeah.
That's okay, because so these are all very, like, conditional suppositions, because wherever we are doing experiments, whatever the condition that we are doing, like, it depends on the circumstances that we are doing. So probably the condition that we are providing also, like, probably why you got the best results out of your experience, because you have conditioned everything, like, the kind of situations and ambience that you have done would be much
Yes.
better, and the kind of the ambience which Vasparaj Kalmat has given is totally different one. I'm not saying that it is not.
I maybe yes.
Yeah, reputation.
I will confirm with him maybe what sex ratio he has taken, whether 1:1 he has taken or 1:2 means that I will confirm with him, because it was just. But publication, there are some publication which says that ecki works bad, but he has not published yet. But I will recheck with him.
Yes.
Okay. There are no questions from the audience side again. So probably somebody is asking questions. Yeah, you can.
Sir, we are interested to raise different Encasia formosa. Sir, we are
Sir, actually your voice is breaking. Your voice is breaking. I don't know whether the madam is able to hear you properly or not.
Little feeble, voice is little feeble.
Madam, we are interested to raise this one. Encasia formosa, madam.
Okay.
We are facing difficulties in bearing, madam, in our
Okay.
Is
Sir,
there
you
any
are from?
standard-
Sir, you are from?
Yes, I am from ASR and farms, madam. Horticulture Research Station, Asikere.
Okay, Matikere. Okay.
Asikere.
Okay. Okay. Yes, sir. Encarsia formosa, Doctor. Their Palampur also they are rearing Encarsia formosa, and
Yeah.
Encarsia
Yeah.
sophia also they are rearing. So yeah. Tell me, sir. Then.
Chandrasekhar.
Chandrasekhar.
Actually,
Yeah, yeah.
Yeah,
sir.
yeah.
Yeah, yeah.
Actually, we have to test against this Rubus-Berlin Varshney, madam. Sorry.
Okay.
Already,
Okay.
Encarsia Guadalupe is there, madam, but it's
Yes.
very
Yes. Yes.
difficult. That's why, madam. We would
Okay.
like to try on Encarsia formosa. Is there any
Okay.
standard protocol? If you want that.
Sir, standard protocol for multiplication. You are asking. Yes, sir. Sir, actually, there is Dr. Selvaraj who has developed this mass production protocol of Encarsia guadeloupi. Please, you can send me a mail. I will attach to him. So he probably, because it is in technology form, so he would be able to tell you how to go ahead. Hello,
Encarsia formosa needed. Guadalupe.
Formosa. Okay, Encarsia formosa. He is not multiplying. He is multiplying guadeloupi. But guadeloupi he is multiplying. Formosa, it is like an inoculative release. He is like earlier when it came in Ducos whitefly, that time he got that Formosa. So he did the inoculative release. He didn't go for the augmentative things. So, but guadeloupi he is multiplying. For that, I can attach you to with him, so that you can discuss how to go ahead for the guadeloupi rearing.
Thank you.
Okay.
Okay, if
The
discussion is over, like the queries from the audience side is over, so I am very thankful to you, ma'am.
So
So you in fact
started with
you got off your start with the biological control versus the natural control, wherein the three segments were classical method and biological control method, conservation method, and augmentative method. And the key players in the augmentative control, like the area of predators and the parasitoids also you talked about, and more than 125 species of insects, inclusive of the predators and the parasitoids you talked about. And augmentation of the parasitoid predators also you talked about, and trichogramma, indigenous and exotic. So which we were like a little skeptical, like we weren't aware of that one. And a trichogramma bacteria against the PBW, which is still under the experimental stage. And the trichogramma chironis strains, which are insecticide resistant, also you throw light on that as well. And the new thing that we came to know about is the Ericilcum eggs being used to culture the Trichogramma chironis and the Embryophagus species. The Trichogramma chironis, so which is of course, like the fall armyworm, so the Spodophora frugiperta, that is the burning problem right now, and the Trichogramma chironis. So that's the best one that you said. Finally, you stated that one as, and the Trichogramma ichia. And the kilo is also against the Tuta absoluta and the bendy borer. And you also talked about the Calinomus rebus against the fall armyworm, the Calinomus formosanus. And the rearing protocol and the dose standardization also that we are working on. And you also touched upon the coconut against the coconut black caterpillar Apanthes species, and the Bracon bravicornis is being experimented against the fall armyworm and the papaya millibug Acerophagus species against that one, and this is also that you discussed, and the Chrysopredators also. So the Chrysopidae family, Hemidopidae family, and the coccinellids, and the new potential predators also, so which are coming forth now. So anthropoids bugs and the Blastoceltus valericensis and mirid bugs, and the few of the Geoporis, the species against the Franklinia schulgi, that is the thrips, and few case studies like the coconuts against this coconut spiraling whitefly Encarsia species, two different species of the Encarsia, and the BIPM also in the rice, wherein you get you mentioned about the net profit that you derived, and you had the outreach of 75,000 hectares of area, and the Telenomus remus and the Trichogramma chironis against the case worm, against the case study, and LSD is covering the large area on the Trichogramma, so under the government sector, and the British mites, and broad mite on the mulberry also, and ASCRP on the biological control, which involves the coconut rugose, wild plant, the sugarcane, fully effect, and the predator cultivation. Predator
protected cultivation, under protected cultivation, also like against the spider mite in the cucumber. So Blastocellus alacrensis, and that is the thing that you covered. And you also said like there are commercial insect trees as such from the private organizations are not there, but still then Angro, US, Raichur, and Chhattisgarh area. These are the areas wherein the biological control, biocontrol units are still operating. And you also said like an NBAIR is not a non-commercial unit. And most important of all, the mainstay of entire the speech was right now, you have the 132 live insect species culture. So just to hear that itself is such a disturbing thing, because I had the opportunity of training only the Helicorpa Nigeras Litra, and it was literally an Herculean task for me. So you stated like you have the 132 live insect cultures. So I really don't know how many man hours you are giving, but what is the staffing position in your lab? But still you have the 25 live culture which is sustainably going on, and more than that, and you also stated like more than 300 egg cards production in a three-story cage, which is the new innovation. Of course, like now 350 biological controls are. Bioagents are like they are fighting against the 100 different species the world, 100 different species the best world over. And you also talked about the commercial establishment. So as a new and the old players in the biological control, and most important of all, I'm amazed to hear like you have the 132 live cultures. So
Yes,
this is really. That is an Herculean task, and how much time you'll be getting for the experiments for your research work. But still and like you have spared your valuable time, and I'm very thankful to you for your the elaborate lecture on the augmentative, status of the augmentative control in the biology and in the fields of the pest control. And not last but not the least, I'm very thankful to all the participants who have been very patient. And most important of all, they have been very active throughout the session, and that was very evident by the way they started asking questions at the end. I'm thankful to Dr. Richa, Varshney, madam, and also the participants. And one and all again. So tomorrow again we have a session at 3 o'clock. And thank you, madam. Thank you very much, and thank you all of you. Thank you.
thank you, sir. Thank you very much. Sir, 1 minute.
Yeah.
Sir, I would like to tell, sir, if anybody has any query regarding like how they get the cultures and everything, I have shared my email. You also have my email ID. Please tell them they can approach me for the cultures and for any help they are seeking for. Because I'm seeing some queries like for rugose spiraling whitefly. So like there is an Acacia guadalupe which you can approach for, and Iceria formosurosea. That is a fungus which is working well against spiraling whitefly. That is also there, and there is a Dr. Y.S. Parmar University is there in Tarepalligudam, Ambajipet, sorry. There is Dr. Chalpati Rao. He is producing that Pseudomallada aster, so he can help you in maintaining that culture and something. If you need any kind of information, please feel free to contact me.
Okay. So you have given the mail ID, man. So if there is a person from the scientific community, so if you have the permission, if you give the permission, I'll also better. What I will do is that I'll direct those persons to you. Okay.
Sure.
Thank you very much for your elaborate lecture, and thank you all the participants. Thank you very much.
Thank you, one and all.